Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, yesterday we started the chapter real numbers. Today let us go for continuing this chapter. Before going to continue, just we shall recall some important points what we learned in yesterday's class. The points are, the first one is an even number, that is a number which is divisible by 2 only. Second one, odd number, a number which is not divisible by 2. Third one, a prime number, a number that has 2 factors only. Fourth one, composite number, that is a number that has more than 2 factors. Fifth one, co-primes. This is very important, please recall it. A pair of numbers having the common factor 1 only, or a number that has a pair of numbers having the common factor 1 only are called co-primes. And in addition to this, we have also come across the different types of numbers. Just to recall them one by one, the very first one is natural numbers, second one whole numbers, third one integers, fourth one rational numbers, fifth one irrational numbers, and sixth one is real numbers. In the chapter real numbers, we are focusing on the properties of positive integers. There are 2 important properties what we learned in yesterday's class. What are those properties? Yes, they are. The first one is Euclid's division algorithm, and second one is fundamental theorem of arithmetic. And it is to be learned in a detailed way in today's class. And one more point we had recalled with respect to Euclid's division algorithm. What is that? It is algorithm. What is an algorithm? A series of well-defined steps which are used for solving a type of problem is called an algorithm. Dear students, we also know that the word algorithm has been taken from the name of a Persian mathematician, he is Al-Khwarizmi. And even we are also very familiar with one more word that is called algebra. The word algebra has been taken from the book written by Al-Khwarizmi. The name of the book is Hisab al-Jabr wa al-Muqabala. Got it? And another important term. Now let me go for explaining that. Dear students, sometimes we feel maths as fun because you just recall some of the terms what I am going to tell you now. Theorem, converse of theorem, corollaries, axioms, postulates, definition, like this. In addition with that, this year one more term is going to be added. That term is lemma. What it is? Lemma. Let me spell out the word lemma. L-E-M-M-A. Then what is lemma? Dear students, we also know that while proving a theorem, we go for many steps. And while proving a theorem, we will also go for using some other statements which were proved already. So such statements, that is the statements which are used for proving another statement is called a lemma. So lemma is a proven statement used for proving another statement. Yes, just note down, write down the definition of lemma. Let me go for writing this. Write down this. A proven statement which is used for proving another statement is called lemma. Once I repeat this, a proven statement which is used for proving another statement is called a lemma, and the plural of lemma is lemmas. Okay, now let's move on to the actual concepts that are given in this chapter. That is, as I said earlier, we are going to focus on two important properties of, very important properties of positive integers. One is Euclid's division algorithm, and the second one is fundamental theorem of arithmetic. Write down the first one, Euclid's division algorithm. It is cited in Euclid's division algorithm. Then what it is? Already we got the bit information about algorithm, and even we are also familiar with the division process. Then just to recall the divisibility of the numbers, here I'll go for taking some of the examples. Don't copy, just keep observing. Here I am going to divide 17 by 6. On dividing 17 by 6, how much are? We know that 17 is not divisible by 6, but nearest one is 12. Hence we can go for 6 2s are 12, and 5 will remain. Then here, what do you call 17? 17 is dividend. Let us represent this dividend with the letter A. What about the number from which given number is divided? It is divisor. Let us represent it with B. Then on dividing, you will get the quotient, call it as Q, and the remainder R. 5 is the remainder. And we also know that how to verify the divisibility. See that 6 into 2 is 12. 12 plus 5 is 17. So I can write this as 17 is equal to 6 into 2 plus 5. Got it? Now let me go for taking another example. Let us divide 15 by 4. Now on dividing 15 by 4, let us see what we'll get. Let us divide 15 by 4. 4 3s are 12. How much will remain? 3 will remain. Here 15 is divisor, 15 is dividend, 4 is divisor, 3 is quotient, and this 3 is remainder. Hence we can write 15 is equal to 4 into 3 plus the remainder 3. I go for one more example. This time let us divide 20 by 4. On dividing 20 by 4, 4, how much are 20? 5s are. 4 5s are 20. What is the remainder? Remainder is 0. Now, 20 is equal to 4 into 5 plus 0. Just go on observing the remainder. In first case, we got remainder 5, second case 3, third case 0. Let us compare the remainder with the 0 with respect to these remainders. Yes, compare remainder 5 with the 0. What do you say? It is greater than 0. Hence, we can write remainder is greater than 0. What about here? In this case also, remainder is greater than 0. Here, remainder, it is equal to 0. So, from this we can come to know that on dividing a number by another number, we get the remainder. That remainder, either it will be equal to 0 or it will be greater than 0. Greater than 0 means It may be any number 1, 2, 3 and so on. Similarly, one more thing we have to observe. Compare remainder with divisor in each case. What do you say? Remainder and divisor. Remainder is 5. Divisor is 6. So 5 is less than 6. Hence we can write R is less than B. That is, remainder is less than the divisor. Here, remainder is less than the divisor. Here also, remainder is less than the divisor B. Here I have represented dividend with A, divisor with B, quotient with Q and remainder with R. So, general statement, you can write it as A equal to BQ plus R. This is one statement, and if you want to summarize this symbolic statement, you can remainder is greater than 0 or equal to 0 and remainder is less than the divisor. Here I write less than the divisor B, or it is greater than or equal to 0. That can be written as 0 is less than or equal to or less than B. 0 is less than or equal to less than R means R is greater than 0. Yeah. With these two statements, important statements, we can go for stating Euclid's division algorithm. And let me tell you one more important thing. Here, when you divide 17 by 6, you get the quotient 2, remainder 5. Are these two unique, quotient and remainder? Of course. On dividing 17 by 6, we always get 2 and 5 as quotient and remainder. Similarly, here on dividing 15 by 4, we get 3 and this 3 as unique integers. And here also 5 and 0, they are also unique integers. When you divide 20 by 4, you will always get 5 as the quotient and 0 as the remainder. Now, let me go for making the statement of Euclid's division algorithm. See that. If A and B are any two positive integers such that A is greater than B, then there exist two unique positive integers. What are those? They are 2 and 5. Here, that is Q and R. And this will satisfy the statement that A equal to BQ or BQ plus R under the condition 0 is less than or equal to R less than B. Got it? Now let me make the statement clearly. See, you have to remember these, what I have encircled. If A and B are any two positive integers such that A is greater than B, then there exist two unique positive integers Q and R satisfying the statement that A equal to BQ plus R, where 0 is less than or equal to R less than B. Got it? This is an important statement to be asked in the examination for 1 mark. So you have to put star mark for this. Once I tell the statement, then I go for writing. You can also copy with me. Euclid's division algorithm states that if A and B are any two positive integers, then there exist two unique positive integers Q and R satisfying A equal to BQ plus R, where 0 is less than or equal to R less than B. So let me write the statement. Please copy with me. Yes. Let us go for writing the statement of Euclid's division algorithm. Write it. If A and B are any two positive integers, then there exist two unique positive integers Q and R. Two unique positive integers Q and R satisfying the statement A equal to BQ plus R, where 0 is less than or equal to R less than B. So close with double inverted comma. Done. Now, just go for taking these examples. Example 1. You need to copy all these. Just this is example 1. Right. 17 divided by 6. Then write this. Second example. Again, you have to copy the same. Third example. On dividing 20 by 4, you will get the statement like this. 20 is equal to 4 into 5 plus 0. If time is not sufficient, please pause the video. Then you can go for copying all the 3. Okay. Finished up. Now, again, come back to the concept. Euclid's division algorithm. See, Euclid's division algorithm, it has some applications, many applications. Among them, just we are going to only 2 applications. One is Euclid's division lemma is used to find out the HCF of given 2 positive integers. And second one is we will go for solving some of the problems on divisibility by using Euclid's division algorithm. Clear up? Right up. Side heading. Applications of EDA. I have written the short form of Euclid's division algorithm, that is EDA. The first one, as I said, it is used to find out the HCF of given 2 positive integers. To find the HCF of given 2 positive integers. Then second one, to solve some problems on divisibility. These are the 2 important applications. Finished up? Okay. Now let us go for solving these problems on EDA in the next part of this chapter. Now we will focus on the second important property of positive integer, that is fundamental theorem of arithmetic. Right. Side heading. Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Here, in this case, just I'll go for taking some of the fundamental concepts what we have already learnt in our previous class. You are very familiar with composite number, even I had told that in the beginning. And second one is factorization. Third one is prime factors or prime numbers. Let us go for using these 3 fundamental concepts to state fundamental theorem of arithmetic. I go for taking some of the composite number. Once I repeat the definition of composite number. A number that has more than 2 factors is called a composite number. Here I take the first example, 70 is a composite number. Then what is factorization? Factorization is the method of expressing the given number as the product of its factors. If prime factors are used, then it is called prime factorization. Let us go for finding the factorization of 78. 78, its prime factorization can be found out like this. It is, what type of number it is? It is an even number. If it is even number, it is divisible by 2. 2, 3 is 6, 1 will remain, it becomes 18. 2 how much is 18? 2 9s are 18. Now 39 is there. 39 is divisible by 3 as well as 13. We can go further. 3 1s are 3. 3 3s are 9. Now we can write 78 as the product of 2, 3 and 13. Got it? Now let me go for taking another example. It is 3150. 3150. It is also an even number. Moreover, it ends with 0. A number which ends with 0 is divisible by 5. 5 is a prime number. You can start with either 5 or 2. It is left to you. Let us go for taking 5, will be easier. 5, 6 are 30. 1 will remain, it is 15 now. 5, 3 are 15, then 0. Now this number is divisible by 3. Why? See, add them, add these digits. 6 plus 3 plus 0 is 9. 9 is the multiple of 3. Hence it is divisible by 3. 3, 2s are 3. 1s are then 0 as it is. 21 is there. 21, it is divisible by 3. 3, 7s are. Keep that 0 as it is. Now 70, it is the multiple of 7. So 7 how much are? 7 1s are 0s are. 7 10s are. Now 10 can be written as 2 5s are or 5 2s are. Now the prime factorization of 3150. 3150 can be written as 5 into 3 into 3 into 7 into 2 into 5. Here there are some prime numbers or prime factors are repeated. Hence I go for writing like this. You can notice that. Let me write 2 as it is. Then 3 is repeated by 2 times. 3 square into 5 also. 5 square into last one is 7. Prime factorization can also be expressed in this way. Clear? Here I have taken 2 composite number and I have written there prime factorization. And when you go for taking the prime factorization of 78, that is 2 into 3 into 13, is it unique? Is it possible to express in other ways? No doubt, it is unique. 78, prime factorization of 78 is always 2 into 3 into 13 only. Prime factorization of 3150 is 2 into 3 square into 5 square into 7 only. So prime factorization is unique. And another very important point to be remembered. Can we write, just I am going to write the prime factorization, you just tell whether it is possible or not. I will write 78 as 2 into 13 into 3. Is it correct? Certainly, it is correct only because same factors. only the order is changed. Can we write 78 as 13 into 2 into 3? That is also right. The factors may be in different order, but the prime factors are unique. Now, based on this example, let us go for stating the fundamental theorem of arithmetic. Here, it is a composite number and it is expressed as its prime factorization. This prime factorization is unique, so the order may be changed. Clear? With this, let me tell the statement clearly. Please listen to me. That your concentration should be completely on my statement, because it is also one of the important statement to be asked in the examination for 1 mark. The statement is, every composite number can be expressed as the product of its prime factors, and this prime factorization is unique apart from the order in which the prime factors occur. Clear? Okay, well, now just go for writing the statement of this with me. Write with me. Right. Every composite number can be expressed in the form of or else you can write in a simple way as expressed as a product of its prime factors. This prime factorization is unique apart from the order in which the prime factors occur. Close with double inverted comma. Finished up. Once we go through the statement, every composite number can be expressed as a product of its prime factors, and this prime factorization is unique apart from the order in which the prime factors occur. Okay, now go for taking just these two examples. Example 1, 78, and this is its prime factorization. Example 2, 3115, and its prime factorization is 3115. It's equal to 2 into 3 square into 5 is repeated by 2 times. 5 square into 7. Again, I have been telling that if time is not sufficient, pause the video and copy that. Now, let's move on to the applications of fundamental theorem of arithmetic. Right. Slide heading. Applications of FTA, fundamental theorem of arithmetic. Even the fundamental theorem of arithmetic has also many applications. Particularly, it is more useful in this chapter because we are going to solve many problems on this concept only. First one, it is used to find out both HCF and LCM. Second one, it is used to prove the irrationality of numbers. Third one, it is used to decide the decimal expansion of the given number is terminating or non-terminating recurring. Yes, please go on writing with me. Applications are important. One is to find the HCF and LCM of positive integers. Second one, to prove irrationality of numbers. Like if you may take the examples like root 2, root 3, root 5. How to prove them? We will go for using this concept. Third one, as I said, to decide the decimal expansion of the number is is terminating or not terminating recurring. Non-terminating recurring. Got it? These are the three important applications. Got it? Okay, now we will move on to the worked examples that are given in the textbook. First, we will go for solving problems on EDA. What is that? Just recall it. It is Euclid's division algorithm. Right. Side D, worked examples. I hope that you have copied. I am going to rub it. Right. Side D, worked examples. In bracket, you may go for writing. So, we are going to solve the problems on EDA, Euclid's division algorithm. As I said, the very first application of Euclid's division algorithm is to find the HCF of given two positive integers. Then HCF. What is HCF? Don't say that it is highest common factor. I asked you the definition, not the full form. The full form of HCF is highest common factor. Then what is HCF? HCF is, as the full form, in that only definition is there, the highest number or the largest number from which the given numbers can be divided completely. That is called the HCF. Just a simple example. I go for taking 4 and 6. Could you tell the largest number from which we can divide these two numbers? 4 can be divided by 2. 6 is also divided by 2. Hence, HCF of these two is 2. Clear? Once I tell the definition, listen carefully. HCF is the highest number or the largest number from which the given numbers can be divided completely. Now, but how? We have different methods to find out the HCF. But in this class, we are going to learn how to find out the HCF by using Euclid's division algorithm. Write up another side heading, not heading, as a question. Find the HCF of the following numbers using Euclid's algorithm or Euclid's division algorithm. Written up? Write down. First one, I go for taking the textbook example only. It is very simple. Write down this. 455 and 42. You are going to find out the HCF of these two numbers. Now please stop writing. Then listen my explanation carefully. Let us go for finding the HCF of these two numbers. In 455 and 42, 455 is greater. I will mention that one. 455 is greater than 42. Then let us go for using Euclid's division algorithm. According to Euclid's division algorithm, you have to divide the bigger number by smaller number. You may get any remainder, but you have to continue. You have to continue the division process till we get the remainder as 0. But how this is? Let us understand that in this problem. According to Euclid's division algorithm, we know that we are very familiar with this statement A equal to BQ plus R. Could you express that in this form? 455 and 42 in that form, A equal to BQ plus R. So, to do that, I go for using the working column. Here, let me divide 455 by 42. You can write it directly. See that 42, ones are 42, 3 will remain next 35. 35 is not divisible. So, you can go for taking 0 and again here 35. Instead of that, directly you can write 442 tens are 420. Then what is the remainder? Remainder is 5. Then 5 minus this is 5 and this is 3. The remainder is 35. Then express this in that form, A equal to BQ plus R. Then we can write 455 dividend is equal to divisor into quotient plus remainder. It is equal to 42 into 10 plus 35. Now observe whether the remainder is 0. No, remainder is 35. So what to do? It should be continued till we get the remainder as 0. Then how to continue that? If remainder is not equal to 0, then from this number you should start dividing the divisor. So here 42. Now 42 is greater than 35. Hence let us go for dividing 42 by 35. 35. Ones are 35. Here 12 minus 5, 7. 3 minus 3, 0. So 7 is the remainder. Here again 42 can be written as 35. Ones are plus 7. Clear? Again you just observe 35 is greater than 7. So you go for dividing 35 by 7. 7 how much are? 7 5s are 35. Remainder is 0. Now we got the remainder 0. Here 35 is equal to 7 into 5 plus 0. So now we continue this process till we get the remainder as 0. Hence the divisor, that is this divisor, will be HCF. Therefore HCF of 455 and 42 is 7. You can check that yourself. You just go for dividing 455 by 7, you will get remainder 0. 42 by 7, you will get remainder 0. Did you understand? I hope that you have all have understood. Now let's move on to another problem. Second problem. Again, here to copy this, just you can go for pausing the video. then copy. After that, again you come back. Let's move on to the second problem. Again, I go for taking second problem from the NCERT text. It is 135 and 225. Here also the same procedure to be followed. Here. Now, first step, observe the greater number. Here 225 is greater than 135. Now let us go for applying Euclid's division algorithm. Then to apply that, you should divide 225 by 135. 135, how much are? You can just go for the table. 135 approximately can be taken. If you take 132 260. See that the given number is smaller than that. Hence we can go for 1s are. 135 1s are 135. Now remainder 0, 12 minus 3 is 9. So it will be 90. Now let us write, according to Euclid's division algorithm, 225 can be written as 135 1s are plus the remainder 90. Now look here, 135 is greater than 90, hence it can be continued. As the remainder is not equal to 0, this procedure should be continued till we get 0 as remainder. Now let us divide 135 by 90. 90, how much are? See, when you go for taking 92, it will be 180, much bigger, hence 1s are. 190, so 90 1s are 90. What will be the remainder? Here 0 goes in 5, then you will get 5, then 30 minus 9 is 4, 45 is the remainder. Then we can write 135 as 90 1s are plus 45. 90 1s are plus 45. Whether remainder is 0? No, it is 45. Should it be continued? Yes. Now this time let us go for dividing 90 by 45. On dividing 90 by 45, 45 how much are? Is exactly divisible. 45 2s are 90. Remainder is 0. Now 90 can be written as 45 2s are plus 0. As the remainder is 0, then the last divisor 45 is the LCM. Therefore, conclusion can also be written in another way. See that here I have written like this. In other form, we can write HCF of 135 and 225, or 225, 135, however you want. 225 and 135 is 45. Here, yes. Again, you should pause the video, then copy. Now let's move on to third. These problems are very simple, and as they have simple numbers, I go for giving you the next problem which is important in the examination point of view. Again, it is also from the NCERT text. Right. Third one. Third one is 4052. Copy this, 4052 and 12,576. 4052 and 12,576. Now you stop writing. Listen my explanation. Here we are going to find out the HCF of these two numbers. First, which is greater one? Greater number is 12,576. Is greater than 4,052. Let us apply Euclid's division algorithm. Now it is bigger number. Nothing to worry, because I will teach in a simple way. Yes, I'll go for using the working column in this. 12,576 should be divided by 4,052. 4,052, how much are? Will you go for taking 1s or 2s or 3s or 4s or? You have to avoid those methods. You can go for using the concept called approximation, which you have learnt in 6th standard. 4,052 is there. Assume that as 4,000. 12,576 is there. Assume that as 12,000. Now 4,000, how much is 12,000? It is 3s. So hence we can go for dividing this number by 4,052. Then 3s are. What is it? 3 2s are. It is 6. 3 5s are 15. Carry 1. 3 zeros are 0 plus 1. 1. 3 4s are 12. 12,156. Now subtract. 6 minus 6. 0. 7 minus 5. 2. 5 minus 1. 4. We have got 420. Now let me write 12,576 as 4,052 into 3 plus 420 divided to divisor plus remainder. Have we got the remainder as 0? No. Then what to do? Should we continue this procedure? Yes. Now 4,052 is greater than 420. Let us divide this. 4,052 by 420. How much that? See that here, assume that for 420, tens how much it is? It will be 4,200. But here how much? 4,052. Then 420 tens cannot be taken. Then what is its previous number? It is 9. We can go for taking 9. Now 9 zeros are 0. 9 twos are 18. Carry 1. 9 fours are 36. Plus 1 37. 3,780. Now it is 2. Subtract this. 15 minus 8. 7. 9 minus 7. 2. 272. This is the remainder. Now I'll write 4,052 is equal to 420 into 9 plus 272. Again, as the remainder is not equal to 0, what is the next step? It should be continue. So 420 is greater than 272. Let us divide 420 by 272. 272. 2s are how much? Approximately. If 250 is there, approximately 2s are 500. But here the number is smaller. Hence you can go for 1s. 272 1s are 272. 10 minus 2, 8. Here 1 will remain. 11 minus 7, 4. 3 will remain. 3 minus 2, 1. 148. Now we can write 420 as 272 into 1 plus the remainder 148. Clear? Now again the remainder is not equal to 0. Continue this procedure, that is Euclid's division algorithm. Now let us divide 272 by 148. 148. Should we take 1s or 2s? If we take 1s, it will be 148. 2s are approximate number. 150, 2s are 300. the number is smaller. Hence go for taking one sum. 148 one sum. 148, then 12 minus 8. It is 4. 6 will remain. 6 minus 4. 2. It is 2 minus 1. 1. 124. Now let me write 272 is equal to 148. Ones are plus. The remainder 124. When I will be explaining, please don't go for writing in between. You have to listen it completely. Then only you can go for copying. Again, look here. 148 is greater than 124. Apply EDN. 140. Directly you can go for, as these two numbers are smaller, you can write it directly. But anyhow, I will show you that. Let us divide 148 by 124. How much are? No doubt ones are 124. How much will remain? Here 8 minus 4, 4, 4 minus 2, 2, 24. Now we can write 148 is equal to 124 ones are plus 24. Interestingly, we are not getting the 0. Hence, the procedure should be continued. 124 is greater than 24. Let us divide 124 by 24. You are familiar with the table 24 because you have learned, you might have learned the tables up to 25 without any error. 24, how much are? 24 ones are, see, 2s are, 3s are. 24 ones are 24, 24 2s are 48, 24 3s are 72, 24 4s are 96, 24 5s are 120. That's simple one. So here 124 is there. You can write 24 5s are 120. 4 will remain. We can write 124 as 24 5s are plus the remainder 4. Again, we don't have 0 in place of remainder. Hence, let us continue. 24. 24. Then 4, how much are? Directly it can be written, but I'll write the last step. On dividing 24 by 4, 4 6 are 24. Remainder is 0. Now we can write 4 6 are 24 plus 0. Anyhow, finally we have come to the end of this problem. That is, the remainder we have got is 0. If remainder is 0, what is the last divisor? This is 4. Therefore, HCF of the given number is 4. Alright. Therefore, the HCF, it is another way of writing the conclusion. In first case, HCF of those two numbers, then HCF, and return the numbers in the bracket. Here I'll write the HCF of given numbers is 4. Okay. Now I hope you have understood and you have to go through that explanation again. Then you pause the video. Afterwards you can go for copying this problem. Now we have got total 3 problems. Let's move on to another problem. This is also very simple one. Again from the textbook. This is 4th one, but from exercise 1.1. But I'll make you to solve the problems given in exercise 1.1 in the order. But in between I'm taking just one problem. You may write, this is 135 and 225. I think you might have finished of it. No. I have taken this numbers particularly because if such simple numbers are there, you can go for finding their HCF without following this working column. You can write it directly. Here, 225. Observe, 225 is greater than 135. And by Euclid's division algorithm, as this number is, these two numbers are simple, you can go for writing the statement without following this working column. See that 135, ones up, how much will remain? 90, right? Directly it can be written in this way. 225 is equal to 135, ones up plus 90, and like this it can be continued. I hope that you will continue and get the final answer. Now, dear students, before going to finish the class, just I'll tell you one important point, that is, what are the concepts we have learned today? All are very important in the examination point of view. Don't neglect, practice them today itself. It may be Euclid's division algorithm, second one, fundamental theorem of arithmetic, and finding the HCF by Euclid's division algorithm. Okay, with this, let us stop the class. Thank you very much.